Okay, in this video I'm going to take you through the notes in your book to give you a little bit of extra help, and this is on fuel cells. So let's first of all start by defining what a fuel cell is. And a fuel cell allows us to generate electricity using a chemical reaction. And fuel cells will continue to generate electricity and produce a voltage until the reactants are used up. So once the reactants have run out, the system will stop. We're looking particularly here at a hydrogen-oxygen fuel cell. And the equation that takes place for this overall is we're going to start with our reactants of hydrogen and oxygen, hence the name for a hydrogen-oxygen fuel cell. And that is going to produce water. If you want to pause the video there yourself and have a go at making the balanced symbol equation, I'm going to do that underneath, and I'm going to remember that hydrogen is diatomic, so is oxygen. I know that water is H2O, and then I'm going to balance this equation. I need a 2 there and a 2 there in order to balance the equation. So the reaction is going to take hydrogen, react it with oxygen inside the fuel cell, and it's going to produce water as the only product. How does it actually happen? I'm sharing this with you just for interest. I think it pulls a lot of our science together and links in with many of the things we've been doing. So this is what the fuel cell will look like. And let's just take you through a couple of key bits. Here we've got our hydrogen coming in, and any hydrogen that doesn't react in this process is then going to go back out here as excess fuel going out of the system. This side here, we've got a platinum anode, and this is forming part of the circuit. In this example, the fuel cell is linked to a motor. So this is hopefully going to make enough electricity in order to make the motor work. And then to complete the fuel cell, we have another platinum electrode. This time this is the cathode to complete the circuit. And on this side, we've got oxygen coming in this side, and what's going to go out here is the waste product of water, and that's going to be released by the system. In between these two, we have to have something to complete the circuit, and in between these two, we have an electrolyte. Remember, that means ions that are loose ions that are able to move about, and the electrolyte, for example, could be phosphoric acid, and there's the formula H3PO4. Let's have a quick look as to what goes on in here. Remember, this is just to illustrate this for you, this bit, and then we'll go back to the notes underneath. So to show you what goes on in here, the hydrogen comes in at this side, and what's going to happen at the anode is the hydrogen is going to be split into hydrogen ions, and in order to form the hydrogen ions, it is going to release electrons. Okay, we need to balance this equation, and we need to scale it up a little bit, and I'll explain why in a moment. So we actually have 2 moles of hydrogen going to make 4 moles of hydrogen ions, and it's going to release 4 moles. I'm just going to make that a bit neater for us. He says it's going to make 4 moles of electrons being released. Because those electrons are being released, this reaction here is representing oxidation. Okay, so we have our hydrogen coming in, our hydrogen comes in, and it is separated into hydrogen ions, and it releases these 4 electrons here. Okay, if I just go back up to the diagram for a moment, so what's going on the surface here are these electrons are being produced, there's my E minus, and they are then going to go up and around the circuit. So there we have electrons moving. Remember, movement of electrons across this circuit is a flow of electricity. That electricity causes the motor to work. The hydrogen ions that we've got, well, they will migrate, move across the electrolyte and come over to this electrode here. Okay, let's look at the cathode and what goes on at the cathode. So at the cathode, we have got oxygen arriving, because oxygen comes in to the cathode. And then what's going to happen here is this oxygen is going to react with the hydrogen ions that have migrated across. And we're going to add to this electrons, and this is going to produce water. Now I'm balancing this as I go to to show you what goes on. So there's the hydrogen ions that have come across. Here's the electrons. Remember, these electrons are part of the circuit that's moving towards this way, and this is forming water, and we know this reaction forms water. Because the oxygen is gaining electrons, this process here is reduction. When you put these two together, what you will notice, in fact, I'll do it this way to show you, is you have two lots of hydrogen making, in fact, we'll write that this way first, 4 lots of hydrogen ions and 4 electrons. And this equation here, we've got O2 plus 4 lots of H plus 4 E minus, making 2 lots of water. What you'll notice is there's 4 hydrogen ions on this side, and there are 4 hydrogen ions on this side of this equation. So when we bring these two together, that's what we're going to try and do, is merge these two. They will cancel out, as will the 4 electrons here and the 4 electrons here. They will go. So what I'm left with is 2 lots of hydrogen. That's going to be here, reacting with 1 lot of oxygen, making 2 lots of water. And that equation that we've just written there is the same equation that we've worked out earlier on here. So you can see how that equation just becomes the equation for this reaction. Okay. Notice it's not a combustion reaction, so we're not burning the hydrogen with the oxygen. We are undertaking the oxidation and reduction reactions in order to do this. Okay. So in simple terms, we're going to write this down as 3 points because it says underneath explain how it produces this. So number 1 is that the hydrogen is oxidized, and that causes it to release electrons. Step 2 in that process is those electrons that have been released, they are creating a flow of electricity. That's what we describe electricity as. It's a flow of electrons. And number 3, the electrons then, they are going to reduce the oxygen at the cathode, and that is going to form water. So in 3 simple steps, that's how we could summarize this reaction. It then says explain why fuel cells are considered better for the environment than petrol. If you think about what we've got here, the only product that is produced directly by the fuel cell is water. Petrol engines, if we had a car running, so a petrol engine, what's the concern there? Is they would also produce carbon dioxide, for example, as a concern, or carbon monoxide, a toxic gas. So that wouldn't be good. Okay, so hopefully that helps with that section of the notes for you.